This is our Lean Six Sigma body of knowledge, and as I mentioned earlier, we have drawn from both IASSC and ASQ body of knowledge. We talk about introduction to Six Sigma, we cover different metrics, the objective of Six Sigma itself, etc. We talk about problem solving tools, we talk about the various levels, the various bells in Six Sigma, roles and responsibilities. We talk about voice of customer, then we talk about project charter and the various tools associated with project charter. We talk about process mapping tools, and we here talk about SIPOC, cross-functional process maps, process flow charts. We talk about VA, NVA and process value analysis. We talk about cause and effect diagram in cause and effect relationship. We talk about the concept of 5Y as well there. We move on further in data types. We are going to talk about what are the different methods in which the data can be collected, how can it be converted from one form to another, and what are the different measuring scales. Data sampling talks about sampling strategy, different approaches to sample the data, and sample size computation. Data collection itself is the physical act of going and collecting the data, and we would give a lot of tips here. As far as the statistics is concerned, in this lecture, that is Intro to Basic Statistics, we talk about descriptive statistics, we talk about central tendency, we talk about measures of dispersion, normal distribution, confidence interval, central limit theorem, and so on. Graphical tools, we are covering histograms, box plots, skewness kurtosis, we're touching upon stem and leaf plot, run charts, scatter diagram, and so on. Process capability, we are talking about CP, CPK, CPM, and we're also talking about long-term and short-term process capability. About theory of hypothesis testing, we're talking about the very purpose of hypothesis tests, how do you frame the statements, what are the different risk levels, and the interpretation of the p-values. We talk about a variety of tools, variety of tests that can be performed, like the z-test, t-test, ANOVA, chi-square, proportions test. Correlation and regression, we talk about what is the concept and how do we apply it in linear and multiple regression. Lean, we talk about variety of tools involved in lean such as MUDA, we're talking about pull system, we're talking about single piece flow and all that stuff. Generating solutions, we're talking about brainstorming techniques and also tools which are used in prioritizing or filtering the solutions. FMEA we cover in greater detail. And finally we go to control plan, where we talk about what is statistical process control and how do you establish control measures in your process on an ongoing basis. So if you look at the structure of a green belt course, if you have done this course from someone else, this structure will help you to ensure that you recap and cover all the necessary topics before you proceed with the black belt curriculum. I can assure you that even our green belt curriculum is a little more exhaustive than what you find in the market. So don't be surprised if some of these tools are not familiar to you. The other thing I want to emphasize before I talk about the black belt curriculum is that in this curriculum, the structure, the flow of the lectures were in line with the DMA-IC, the DMAC methodology. But in the black belt curriculum, you wouldn't find that structure. The tools would be mostly statistical in nature, and we would be emphasizing more on the measure and analyze phase. So bulk of the tools would be in that phase. So we're not going to see the DMA-IC rigor or the structure in the black belt course. That doesn't mean that rigor is not important at the black belt level. It is more important than at the green belt level. But at a green belt level, you have learned the concept. So I'm not going to emphasize on that rigor right now in the black belt course. Let's then move ahead and talk about the black belt body of knowledge. In the black belt body of knowledge, we touch upon black belt leadership skills, change management skills, Six Sigma matrix. Mainly we're going to talk about RTY in that. We're talking about business process management system and how do you apply it. We're going to talk about measurement system analysis, and we're going to deal with all the difficult concepts. We're going to take up ANOVA, gauge RNR. We're going to talk about Kappa method in discrete data. We're going to talk about crossed and nested designs. In statistical techniques, we're going to recap and at the same time go a little deeper. We're going to talk about probability curves, different concepts of probability, how you can apply them. We're going to talk about shape, scale and location parameters, different types of distributions, normal, variable, exponential, binomial, Poisson and other distributions. Where do you apply them? If there are questions asked about these distributions, not theoretical questions but problems relating to the probability, relating to the percentage of area covered under the curve and so on, how do you solve those problems in practical scenarios? We're going to take examples and deal with it. If there is a raw distribution and if you don't know how to identify it, we'll teach you how to do that. Central limit theorem, what is it, what is standard error, etc. will be covered in greater detail with examples. In sampling distributions, we'll talk about degrees of freedom, we talk about t distribution, chi-square, f distribution, all these distributions we're going to take in detail and go point by point. We will also cover confidence intervals and prediction intervals. In sampling, we will cover sampling of estimates, which means if you want to do a data collection, how do you compute the sampling? We covered it at green belt level, but we're going to use Minitab to solve the problem here. And we will also take up scenarios where we want to apply a sample size correction for finite population. In advanced graphical tools, we will talk about a variety of tools that you see on the screen, and we will cover all this with practical examples. In statistics, that is inferential statistics, we will touch upon some of the concepts that we again mentioned in the green belt level, but we're going to go a little bit more into the theory to understand questions like why we have to do this. In other scenarios, what should you do? At a black belt level, it's going to be a little more of application orientation, so we'll take examples and cover these concepts. We will talk about power and sample size. Very, very important concept for all your hypothesis testing. We will talk about hypothesis tests itself, different types of chi-square test, etc. In ANOVA, we will take one-way, two-way, balanced, unbalanced ANOVA. General linear model, we will cover that. Correlation and regression, we will go in detail. We will talk about multiple linear regression. We will talk about logistic regression, etc. We will also talk about how to build predictive models. Nonlinear correlation, Spearman's correlation. We will also talk about how to deal with non-normal data. How do you handle transformation, Box-Cox and Johnson transformation. Process capability for various scenarios, starting from variable data, binomial data, normal data, Poisson data. We will cover all that. Non-parametric tests, again something that we will cover in greater detail, variety of tests. Finally, we will talk about design of experiments. We will talk about full factorial, we will talk about partial factorial experiments, and then we will also do some examples on these to understand when, where and how we can apply this. Finally, before we wrap this course, we will touch upon some of the advanced statistical process control charts such as X-bar S chart, Kumsum chart and EWMA chart. So that is by and large the black belt curriculum. By now you will realize that this is going to be an advanced course, and unless you're not really familiar with the basic concepts, you would not be able to proceed with this. So with that note, I'm going to wrap up this lecture.